we have a new question where we are given two loads A and B, and it is asked to find a force P which will impede the motion of B in downward direction. So, and we are given coefficient of friction for this surface between A and the surface is 0.4, and for block B and the surface is 0.3. This is block B. So now we interpret the data that we have. There's a pulley and there are two blocks. The weight of the first block is given as 500 kilograms. So uh, it will be resolved in two components. First is the horizontal component, which is 500 sine of 50 degrees, and then the vertical component, that is 500 cos of 50 degrees. We'll spend some more time at block A. Block A will also experience a reactional force, which will be RA, and now also we have to calculate for a condition that block B moves downwards. So when B moves downwards, A will move upwards. So the direction of friction for A will be in downward direction, and the direction of friction for B will be in upward direction. So the friction coefficient is given by 0.4 into R using Coulomb's law for block A in downward direction, and 0.3 into R in upward direction for block B. And now for block B, the weight is 750 newtons. So we resolve it in horizontal and vertical components, local horizontal and vertical components. So the local horizontal component is given by 750 sine of 30 degrees, and the local vertical component is given by 750 cos of 30 degrees. These two angles are 50 and 30 degrees respectively. RB is the reactional force which is acting on block B, and 0.3 R is the frictional force which is acting in upward direction for block B. So this is what we interpret from the question that we have. We have to find the force P which is asked in the question. So we go about it starting from block A, because we need to find this tension, and since more number of unknowns are there at B side, we will start with A. At A side, first we do summation of forces in F vertical direction, that is Fy, and we equate it to 0 for block A. Now we'll see. For block A, there is one force acting vertically downwards, which is 500 cos of 50 degrees, which is acting downwards, and RA is acting in upward direction. So we have plus RA, and we equate this to 0. So this will help us to find A. We directly put the values in calculator and we get the value of RA, a first value. The next is we take the horizontal components, summation of horizontal components at block A, and we equate this to 0. Now, the horizontal component of the weight is in the negative x direction, so it will be minus 500. Even this one is minus, so, because it is in downward direction. This is minus 500 sine of 50 degrees, and the reactional force is also acting in this direction. So this will be minus 0.4 into RA that we have calculated. So this is known to us. The only unknown is T, which is in positive direction. So plus TA, and we equate this to 0. So RA is already known to us. Only thing is TA. So by calculating, we get TA is equal to 500 sorry, 511.3. This is actually this comes out to be 9.58. So these are the two values. Why have we calculated TA? Because for finding the values at block B side, we need this force, this tension wala force. So this we have calculated through block A. So this was the only reason why we went to block A. Now block A is done. Now the next one is block B. At block B, we first find the reactional force RB. So for that we need to take summation of Fy, which is for vertical forces. RB is acting in positive direction, so it is positive. The weight, the vertical component of the weight is acting downward, so this is minus 750 cos of 30 degrees. And we again equate this to 0. So what we get is RB is now equal to 649.52. So now we have the reactional force with us at B. We need to find P, which is in horizontal x, positive x direction. We have calculated T, and now we have the reactional force as well. So we can directly jump to summation Fx and equate this to 0. P is in positive x direction, so it is positive. T is in negative x direction, so it is negative. We already have the value of T. TA is also equal to TB because it is a frictionless pulley and it is given to us that this is a frictionless pulley. So P, T, now 0.3 R, which is the frictional force which will act in negative direction, so this is minus 0.3 R and this is RB and this is also calculated. And plus the horizontal component of weight, which is plus 750 sine of 30 degrees, and we equate this to 0. So this will help us to find the force P 331.44. This is a typical university question where we have to solve for one part, get some data and put this data in the required part portion where it was, for our case, it was the tension in this cord, cable or string that we had, and then applying the force, applying the equilibrium conditions at this point, at this section, we get the required force P, which will impede the motion of B.